compatible with a Windows machine. So what normally we do is we normally go with the virtual machines, but then developers do find it switching from one place to another, as that's one of the issues. And the virtual machines must be maintained just like another machine, because you need certain OS patches or installations or configurations or anything. That's just like you are actually maintaining that machine on that particular case. And the virtual machines are going to get a share of memory, CPU, stuff from the host machine. So we normally, when you install a virtual machine, you normally dedicate it while setting it up. You specify the memory, you specify the CPU, how much. So if you are using, let's say, 3 or 4 virtual machines on a server, so it means the server is facing all that pressure from different virtual machines. So these are the different concerns that goes into virtual machines. And the another one, which normally is, because all the virtual machines which you run, if something happens to the host server, so we normally have to take the backups of all those virtual machines, just like a normal backup which we take. And then we have to restore it, everything, like again, we set up a new server, restore all those virtual machines. And it's a kind of a little bit, I would say, an overhead for the infrastructure guys. Okay, so what are Docker? So then all these problems can be removed with Dockers and containers, but what exactly they are and what is the purpose of these Dockers and containers? So Docker is a kind of a platform as a service model, right? It's a PaaS service, and it uses the OS level virtualization to deliver software in packages named as containers, right? So we are not actually virtualizing the hardware, rather we are virtualizing the OS. So it means the hardware still remains the same. You just install one operating system, that's all. But you can run different, let's say, software capabilities in the form of a containers. Container is a kind of a small encapsulated image which you can create and you can run it. And it does not need any, let's say, Linux, or if you want to run a Linux, it can run Linux. If you want to run it on Windows, it can run on Windows. So that's the OS level virtualization rather than the what we call it as a hardware virtualization. The second thing is Docker can package the application and its dependencies in a virtual container. So the virtual container is nothing but a container, and you can run it on Linux, on Windows, on Mac. So it means you don't have to worry about which device category you are using, which operating system you are using. You're just running it, and you can run it on premises, public or private cloud, wherever you want to run. So we'll actually see how to run a container and see how we can use this Docker and container to work with databases. Containers, when you say a container, so this is technically an isolated one. So let's say if I want to run a container for SQL Server, which will demonstrate, so it's technically isolated from another container. So I may run a container for SQL Server, I may run a container for Oracle, I may run a container for, so it means I can technically run so many containers within that, and they are all separated. They use the same operating system kernel, and they definitely consume less resources than the virtual machine. So virtual machines, you need to specify how much RAM they need, CPU they need, or processing power they need. But here, they are just using the single operating system kernel and using very less resources as compared to the virtual machine. So that's the part and parcel of Dockers and containers. And Docker service, it was developed in 2013. It offers both free and premium tiers. The software that hosts the containers is called as the Docker engine, and was first started in 2013 and is developed by Docker Incorporation. So it has both free and premium tiers. Initially it was free, but now last year they made it like in different tiers. So you can still use it as a free if you're using it for a personal one. But in case you have employees like 250 or more than employees, you would have to pay the premium for that. Okay. So let's try to understand what is the Docker and containers architecture. So this is the first of the thing which you need to understand, that is the Docker client. Now, Docker client is technically through which you work with the Docker. Like it is a command line arguments, you give your Docker commands, everything, whatever you want to work would work with the Docker client. So when you download the Docker software, which I'll show you out, and you install it, these are all the commands which you'll use to interact with the Docker engine or other things. So that's technically your Docker client. You can run a variety of commands. I've just mentioned few commands. Now, the Docker client, it interacts with the Docker engine. Now, mind it, now Docker engine means the core. So Docker engine has primarily one of the major things that runs in the background that is called as a Docker daemon. So this is a process, a background process that runs, and all the commands which we can use, Docker pull, Docker build, Docker run, we can interact with the Docker daemon. And Docker daemon actually uses the Docker images, which means this one. So you can have an image for SQL Server, you can have an image for .NET Core, you can have an image for Nginx, a Redis cache, a MySQL database. And then from these images, you can run your containers, like multiple containers. So I can run one container for .NET Core application, I can run a container for Redis, one container for Nginx, I can run multiple containers. I can stop those containers, I can run those containers, I can resume those containers, I can delete those containers, but they are coming from the images which are ready-made images in the form of a Docker image. We call it as a Docker image. And these images are provided by all these standard companies. So for example, a .NET Core, I'll show you out. A .NET Core image would be provided by Microsoft. If I want to run SQL Server as a Docker container, so I would have to go onto the Microsoft and get the SQL Server image, and I can use it. MySQL is provided by Oracle because it has been bought by that. Redis is provided by their individual organization. So that's how the setup goes. Any questions? Okay, let's continue. If you have any questions, let me know, please. So the last part in this architecture is, I'm sorry, do you have any questions?
I think no one has asked any questions, sir. Please.
Okay, thank you. Yeah. So the last part of this architecture is the Docker Hub repo. Now, what is a repository? Repo means a repository where all those images are actually like hosted by the respective companies. That's very, very important, which I was saying. So this is a public repository, and from here, you can get your images directly, like I want a .NET Core image. So you can use the Docker client to get an image. So this would use the Docker Hub repository to get that image and pull it into your local stuff. And once the image is there, then you want to run it in the form of a container, you can run it as a container. So technically, there are two things which is very, very important. One is the containers and one is the images. The images are directly available from the Docker Hub repo. That is, we'll see what is a Docker Hub repo where the Docker images are there, and we are gonna pull this image into our Docker engine over here, and then from that engine, from that image, we can run a container. So once I'll actually practically show you, so we'll come to know what exactly it is and how it would run. Okay, so this is technically, I'm just giving you at a very high level overview the basic architecture of how a Docker works. So you would find three parts to that. One is Docker client, one is the Docker engine. So Docker client and Docker engine, they would run on your PC whenever you install Docker. And Docker Hub repo is just like a remote repository, which I'll show you. It's like a website where you can go find images. You can even create your own images and push out there. But these are all the images. If you want to try out a Docker image for .NET, you can run that image, and then it would definitely work for you. Right? Okay, so I hope this is like something kind of at a high level, but still you should be able to, because for me, when I started off with Docker, almost like 5-6 years back, it took me like 3-4 months to really understand what exactly they are. So this is like all my experience I've put it into and made it in a very, very simple format so that you have a Docker client, you have a Docker engine, and you have a Docker Hub repo, and we'll see these things in the action. Okay, so So now when you say RDBMS with Dockers and containers, so now what exactly that means? So what it means is, let's say there are like multiple RDBMS systems that can be independently run on host machines, right? So technically right now, as a part of your curriculum, or even if you are like, let's say doing some job or part-time job or anywhere, you might be seeing that people are running, let's say SQL Server, right? So it means there is a SQL Server, somebody installs SQL Server on a server, might be on a VM machine somewhere, right? And then you can access that, right? So there is a server out there, there is a physical server. The physical server might be running a virtual machine, but still those things are there, right? You might be using an Oracle database. Okay, I can install Oracle database. The developer version comes free. I can just come and install it. You can install a MongoDB. We'll see a no. I hope you understand MongoDB. It's more likely a NoSQL environment where the databases are not what you call as normalized. Rather, they are more likely in a different format. So that's what we use. And we can also run like MariaDB or MySQL or any other databases, right? So it means if I have to run any of the databases, the only provision I have is I need to go onto the website, download their software, install that software locally, or install that software onto a server machine and then start accessing it. And I think so everyone, majority of you might have worked with some databases and you might have done it in the same way, right? So what then Dockers and containers they bring in? Because Dockers and containers, they are virtualized software. They run in containers, small packaged environment. So technically, the RDBMS with Dockers is a huge hit. And the reason for that is we don't need to like do a full installation of RDBMS. So you don't need like, you don't have a, like you want to try out a SQL Server, you don't have the SQL Server installation CD, or you don't have the access to SQL Server or a NoSQL database, no worries. You can just use the Docker image, download it. Docker images are free. They are freely available. You can download it, try it, run it as a container, and then do it, right? So technically, you are not putting the full installation of any RDBMS system, might be a SQL Server, might be Oracle, might be NoSQL or anything. That's the first advantage you'll get. So in fact, for the last, I would say 5 years, I don't install now RDBMS or anything. I just install Dockers and then use them. And then, yeah, even for my development or for my other projects, I just use those. That's one of the fundamental advantages you get. The second is it provides cross-platform support. So just imagine SQL Server, everybody knows it's a Microsoft product, and Microsoft never allowed any product to work on other operating system except for Windows. But because you have a Docker image, okay, it's a cross-platform. You take that Docker image, you want to run it on Linux, you can run it on Linux. On Windows, you can run it on Windows. You want to run it on Mac, even you can run it on Mac, right? So that's the beauty of Docker's usage, and whether you want to use an RDBMS or anything, that's the beauty of it, right? And last of the advantage, I won't say this is the least one, this is the most important one. If you guys have understood or you have read about microservices-based development, which is like a buzzword, if you understand microservices development today, I guarantee you out in Canada, you will be the first person to be hired in like quick succession. I'm not aware about Indian market right now, how they are like implementing microservices or anything, but over here, every single development is microservices based. People are changing it at like and I've been working with so many clients, they are all using microservices based deployment. So microservices means you deploy small services. You don't deploy one website, you deploy small services as like number of services in the form of website or anything. And then typically what happened was like initially you have one website and one database, right? So that's how it would work. Now in the microservice, you have one service, one database. Second service, another database. Third service, another database. So that's how typically it would work. So the microservices the another thing which is important is they cannot work without Dockers and containers. So that's why Docker and containers became very, very popular, because people are flocking to microservices-based development. So that's why Dockers and containers, they became popular. And now they say, hey, I don't need like one database. For one service, you need every individual databases. So for per service pattern, what we call it, so we need containerization. So that's why RDBMS systems or no RDB or no SQL systems, they need Dockers and containers. So that's the one of the fundamental reasons for the RDBMS to that. And the microservices orchestration tools, like if you have like studied or read about it, whether it is Kubernetes, we normally call it as KAS, or Docker Swarm or OpenShift, we all need containers as deployed like microservices. So you need containers. You cannot work with microservices without containers, because that's the fundamental philosophy of microservices pattern, right? So that's why Docker and containers is becoming very, very important. You not only need for development, you need it for RDBMS also, you need for development also. You're running everything on Docker and containers nowadays. It's becoming more easier for us. Okay, so yeah, that's kind of, I wanted to keep it short and precise. Let's go for a demo with the Dockers and containers, and we'll see. I'll try to kind of align you like, okay, this is what we started with certain those slides which I demoed, and then what we are exactly going to demo it. Before we go on to the actual demo, any questions or any queries? Anyone? Any queries? Any questions?
Someone had raised their hand while sir was talking a few minutes back.
Yep, anyone, before we delve into it, if you want to ask or clarify something, yep.
Anyone wants to ask a question?
Okay, that's fine. No worries. We can still take those questions afterwards once you feel you have the demo. Okay, so let's go back, and I'll just revisit my slide. And this is one of the important things, like a Docker client, a Docker engine, and a Docker hub. So let's firstly see what a Docker hub is. I said it's a public repository where all those images are available. So if you just go on to, let's say you search on Docker hub, just search a Docker hub on Google. This is the first link you'll get, that's named as hub.docker.com. So this is your Docker Hub container image library, right? So this is there. You can create your own account over here. It has a free version. So let me use mine. Okay, let's see. Okay, so close it, right? Okay, so if you see, these are all the images which I created, right? This is my repository. I can create multiple repositories, and this is kind of all the images which I'm doing it for a client, so where we are developing a kind of a shopping website. But this is all microservices based. It's an e-commerce website. We have like products, we have searching, you have shopping clients. A lot of stuff is happening in this, right? Now, if you can just search for here like Docker Hub, I'll say Microsoft, let's say, and you just want to, let's say, go in for this one, and Azure Cosmos DB emulator. You can search for that. So there is one image over here, right? So you can use this command to pull it out. Okay, so let's say if I don't search it over here, I just search as a Google one. I say Microsoft SQL Server Docker image, right? So if you see, I'll get the first link, which is again hub.docker.com. So you click on that, you go there, and if you see, so this is provided by Microsoft. It is an official image for Microsoft Server on Linux for Docker Engine. So it means you don't have to like you can still run this image on Mac OS also, except for if you have worked with the M1 Macs where the Apple has developed their own silicon, but you can use this image across Mac and the Intel platforms or anywhere, right? So it doesn't really matter at all. And there are tags. The tags are normally determining, okay, which one you want to use. You want to use a SQL Server 2019, you want to use a 2017, or like any other. I'm sorry. Okay, so any one of the images you can use. So we'll actually see how to use this image and actually run this SQL Server. So technically, I'm not going to install any SQL Server. I'll just use this image, use it in the container, and run it as a container, and then connect it. I can work with SQL Server the way it wants, right? Let's say you want to use a ASP.NET Core. Okay, so if you want to use, you might be using an ASP.NET Core 3.1 runtime, a Core runtime. These are all the images from like Microsoft, right? These are the official images. You want to use, let's say, for Redis. Okay, so this is an official image from Redis. Redis is like a cached database, a key value pair, right? You can use it. So any one of the images, these are the standard images, and you can like categorize the images. You can search for architectures or anything, or Intel-based processors or Linux or Windows-based or anything, right? Virtually, it gives you the virtualization for operating system, so it doesn't really matter. So this is all Docker Hub. You can upgrade this, like if you want to have the one which I'm using. I did upgrade for a certain project, but right now I don't need it, so I'm using the personal one. The personal one comes free. It comes with certain limitations, but you can always upgrade it. If you say you upgrade it, okay, so you can use a personal, which I'm right now using, which is at $0, a pro version, which has a Docker desktop, unlimited private repositories, 5,000 image pulls like you want. Automatically, the image should be deployed somewhere, all those things, right? So you can upgrade your plans. You can stop and upgrade it at any time. So this is what the Docker Hub repository, what I was talking about, right? Now, this is a centralized repository. Docker Hub is one repository, which we are talking right now, but there are so many repositories like Azure. If you work with cloud, Azure has a separate repository, AWS has a separate one, Google has a separate one, which we can use it. But right now we are just using the Docker Hub repo, right? Okay, now the second thing which we are going to now understand is this Docker client. So let's go on to once again into here, and let's try searching it out for. So we'll say Docker desktop download. You just click that download. And this is the one, which is the Docker desktop download. So you can install with the Mac with the Intel chip, Mac with this, with the Apple chip, or also available for Windows. You can use this one. So it starts downloading this Docker desktop, right? It's almost like 500 MB. So depending upon your machine and internet connection, it takes a while to download it. Okay, so once you get that, now the Docker desktop, when you install it, right, you run it, it just gets installed. And I have already a Docker, so it runs it in this format. It shows you this, like the Docker is running, it has a dashboard, settings, it checks for the updates, and so many other things, right, about Docker desktop, window containers or Linux container. Right now I'm running on Linux containers, so it doesn't really matter which containers, but Linux containers are much more powerful and they are widely used. So this is the one. So once you get it installed, you can work from the, let's say if I show you the dashboard. So the dashboard is where the Docker, like it is, you are running some images or containers or apps. So right now it is nothing. It's just a simple installation. It shows me it is running this. Okay, but majority of the work in Dockers and containers, that's done through what you call as the command line. Now, again, going back to our presentation. So once you get this installed, so Docker client and Docker engine gets installed. This we have already seen because it's a Docker Hub repository from where the images can be downloaded. So now I can use the Docker client to work with these two guys, right? Because Docker engine is automatically running. And how I can verify it? So if you just go on, the first thing you can just check it out is, let me just increase the font size. Okay, so if you just run a Docker, let's say once you install it, it's a simple installation, just like next, nothing major thing. So once you install it, you run Docker. Okay, so this gives you like this. It verifies, okay, Docker is installed, everything looks good. Okay, now let's say I just want to check the Docker version. Okay, so it gives me, okay, which Docker version I'm running, Docker desktop, some other information about that. Okay, makes sense. So it means my Docker, if I go back to slide, Docker client and Docker engine is running on my local one, perfectly fine. Now I just want to see, I want to check which images are available, which containers are available. So if you see, I can just run a command called as Docker images. Now if I run this Docker images command, it would show me the local images over here, all the images over here, not over here, because they are in the Docker Hub repository. So if I want to use an image, I have to make a pull to get the image from the hub into the images. So let's firstly see how many images are running. So we'll just go on to the this and we'll say Docker images. So if I see, okay, so there is no image right now. So it means in my personal computer, in my Docker engine, so my containers and my images, I've just seen the images, it is empty because I don't have any image right now. So what I can do is I can pull an image. Let's say I want to run a SQL server, so I'll pull an image and store it over here. That's more important. Okay, we'll do that. We'll practice because that's what we are going to do in this session. And if I want to see the running containers, because from the images, you can run the containers. So you can run another command, Docker, let's say this ps-a. So this shows you all the running containers. And if you see, this shows me container ID, from which image it is there, command or anything. So I don't have even a container. So technically, in my Docker engine, I'm running this Docker daemon, but there is no container, no image. But yes, my Docker client is working, my Docker engine is also working. And in the case of Docker Hub repo, yes, that's a website from where I can pull the images and which I'm gonna pull it. So let's start with a very basic one. I think so SQL Server is something which all people might have worked with some or the other way. So let's use the SQL Server command to exactly like download it and use it inside our case. Okay, so what we are going to do over here is I have all these commands like this one. So let's say I'm just going to use this command and let's try that. So the first command which we are going to do, I'm again expressing you, we are going to pull SQL Server from the Docker Hub repository because all the images are stored over there. From the repository, I'm going to make a pull request and the image would be pulled into my local Docker engine. It would be stored and we can see it like it is actually pulled. So we are not going to install SQL Server. We are just going to use SQL Server Docker image, run it as a container, and then boom, you can interact it. I'll show you how you create tables. It's virtually like everything works the same. So let's do that. So this is the command which we'll use. Now what we are trying to do over here is we are saying Docker pull. I say, please pull the image from this repository, right? And because Microsoft has given the tags also, so I'm specifying the tag 2019 latest, right? So I'm saying I want to pull Microsoft's SQL Server 2019, the latest Docker image, right? So I'll get that. Once I press enter, it starts pulling that particular image. So if you see, it is pulling the image from Microsoft SQL Server Docker image from the Docker Hub repository and going to store it in your local Docker engine. So it all depends upon how much bandwidth you have, because it is going to pull all those parts and then join them together into a single image out here, right? So let's give this a couple of seconds. I think so it would be done within a few seconds, and then we'll use it the next way. Okay, so extracting. Okay, looks it's almost extracting 406.5 MB. Okay, almost done. Okay, so this is extracted. The other part is also okay. So everything looked fine. It has pulled the image from the SQL Server repository in the Docker Hub. So if we go back, what has that done is it pulled this image, the SQL Server image, and pulled it onto the local Docker, right? And how can we verify it? Like, okay, it pulled it, yes, it gave a message, downloaded new image, that's fine. So now I can just run the command again, Docker images. So because it has pulled it and all the images would be stored in my local repository, not on the, because I've already pulled it, so it is in my local repository. So if I go back and check the images, yeah, so you would see in my local repository, this is the image which I pulled. This is the tag. This is the image ID created. Just don't worry about these dates because I've been using Docker. I have not installed it first time. So that's why. And it gets the size on everything. And yes, the image is there. But now.
Sir, may I please interrupt? Sorry.
Sure.
Sir, the presentation needs to be full screen as students are not able to see. Can you please make that?
Sure. I'm sorry. I'll definitely do that. Okay. So
in fact, even on YouTube, the presentation is appearing very, very small. And the viewers there are also requesting that it should be done. So I'm not sure what is the problem. But can the students please respond? Because
I can little bit increase the, let's say this.
Sir, there is a full screen arrow to the right of your presentation.
The full screen, ma'am, when I run it, it is already, for me, it is in the complete full screen.
Okay.
Yeah, so because this is the complete full screen for me, beyond that, I cannot make it. But over here, for example, I can zoom in if they are not able to.
Not that way. I think maybe the students can please switch off the cameras because let only sir be visible. I request all the students to switch off the camera. Sorry for the confusion. But people on YouTube are not able to see the presentation and they are requesting.
Okay. I understand. But I'm actually, ma'am, running it in the full mode only.
Okay, sir. Okay.
Yeah. Okay. So this one, what I was talking about is we have already now pulled the image and it is stored in your local images, which is here. And how did we check it? We checked it like this. So we gave a command called as Docker images, and it told us, okay, we have a repository, local repository, we have an image, we have a tag, we have an image ID created and something like that. Because I've been running Dockers and containers for so many years. So this, please don't see this created 2 months ago or anything. This would be something based upon different parameters. So that's fine. But now, if I want to see, because the image is already there, so let's go back to the presentation. And if we see, are we still running some containers or not? Because the image is definitely there. But if we just want to see it as in the form of containers, I can just give this command, ps-a, and then it still says, oh, there is no container. The container is still empty. So we have an image, but we are not running it in the form of a container. Okay. Now, what we are going to do is, because we have the image, local image, now we are going to run this in the form of a full-fledged container, right? So once you run this in the form of a container, this is actually like using it just like you installed SQL Server. It is working locally. You can create tables, you can create databases or anything, and we'll see that. So for running that image, so this is the command. I'll post these commands out there for you. So otherwise, these commands are all available online also on the Google, the Docker Hub. So if we want to run this, so let's try this command. So this command is running. Now what it is trying to do is it is trying to run the container from that image which we downloaded. And in order to run Microsoft SQL Server in the form of a container, we are saying Docker run So we want to run that. So just like we say docker pull, so there's another command called as docker run. And there's -e where we specify the string for initialization, where we are accepting the end user license agreement, and we are specifying the SQL Server password. Okay, I kept the password as lovely university 123 and exclamation sign, something like that. And we are specifying a port. Now, by default, the SQL Server has a port called as 1433. That's the by default port, right? Now, if you want to use that port, because this port refers to the initial port, like on the left-hand side, this port refers to the port which would be used on your host machine, right? So because Docker is actually running in the virtualization mode, it is running. So we say whenever somebody connects to 1433, you should immediately map it to the Docker port, which we are again specifying the same, like 1433. So we are not changing that. So we are running it in both ways in the same thing. And then you're also specifying the name. Now, name is something very important, because if I want to stop this container, if I want to see the container activities, I can just give some container name. It's easy for me to stop, restart, or do anything. But sometimes what happens is if the container is an issue or anything, you can still use it without your name, but then you would have to remember our container ID, which is a junk characters, which is difficult to start with. And then it says, like, run this complete container with all these parameters, and then you specify from which image, because if you need, you can only run container from an image. So if you are running a SQL Server container, let's say this is a SQL Server container, you need to specify the image from where you are running it, right? So you go on to this, and then you specify this is the image name from where we want to run the container, right? So that's typically the command which we'll use. And once we press enter, it kind of starts it and gives you this hash ID, which means the container has successfully started off. In order to see that, ps-a, to see all your containers, you see this command. Okay, so you ran this container ID. This is the container ID, a junk characters which has been given. It is running from which image? This is the image name. This is the command created status ports, and these are the ports which run. And this is the container name which we gave, SQL Server Docker, right? So our container is 100% running. This full one of the containers is running from one of the images of SQL Server which we pulled from Docker Hub, right? Now, because the container image is running, okay, let's go and now use it. So it's a full-fledged database. So I've just used a SQL Server Management Studio, which all of you might be using it for working with the SQL Server. So you can use this, or you can use the Azure Data Studio, or anyone to work with that, and it can definitely connect with you. Okay, so because now we don't have the SQL Server installation, we never installed it. We just ran a container image. Now the container is actually running, listening on port 1433 and 1433. 1433 on the left-hand side means the port which the host machine runs, and 1433 is the actual Docker port in the virtualized mode to which we map it out. Okay, so now what we'll do is we'll go over here. Let's say we say this is, unfortunately it is small. I can use the Azure Studio, but let me try connecting it. So this is localhost, comma 1433. That's the port, SA, and then the password, right? Now, if you remember, we just gave the password as lovely university 123, let's say exclamation sign, something like that. So if I just try to connect it, lovely university 12, I'm sorry, let me just see, exclamation sign, connected. Okay, so it is all connected. Now you are actually connected on to this guy, like this Docker. Okay, so if you see, because it's a new Docker, if you see your databases, you don't have any database, right? It's a full-fledged SQL Server being run in a Docker image. Now you want to create a new database, let's say. You want to create anything. So let's say I just want to create a lovely, okay, just add it. Okay, so you get the full-fledged. Now this database is actually like running within the Docker. And because it's a Linux Docker, Linux-based Docker, so if you see its properties, Unfortunately, this is small, but if you see this, it is running in Linux server, that is var opt ms SQL data, because you can just, this is beyond the scope of this session, but that's how it's not running on your local, it is running in within a container environment, right? And it's just like a normal database. So you want to, let's say, do a query. I can just enlarge this. Let's open this up. Okay, so let's say, create table, and I will say dpt. So once you create that table with a small, let's say 2 columns, we'll create it so that we can just have an idea how exactly it looks like. It just behaves the normal way, right? So department number is an integer, and D name is, let's say, and variable character, let's say 500, something like that, right? So you just give it, run this, execute it. Okay, so the command completed successfully. So now if you refresh this, you see the tables. Okay, so you get those. So department table, you can edit it, you can, like, whatever the way you want to do it, you can do anything. So it's not a SQL server that is running like a full-fledged installation, rather a SQL server which is running in the form of a Docker image, right? Complete Docker image. Now, the beauty is, once you are done, you can use this Docker image to, like, if you're using it in a microservices based environment or anyone, you can actually push it to a DevOps pipeline. It can automatically be deployed, or you can run it on Kubernetes or anywhere. So it's just like no SQL Server installation, nothing. Use a Docker image, any platform, anywhere, and start using it. That's the beauty of that, right? Now, just like, because this Docker image is running, if I just want to stop it, I can just say Docker stop SQL Server Docker. That's the reason I was saying, if you can give the command like the Docker name or the name of the container, it's easy. Because if you don't specify this, then you would have to use this container ID, which is like a kind of a junk characters, which is a little bit difficult. So you can stop that. So the container would be stopped, but the container still exists, right? So if you see that Docker ps -a, you can check it out. Yep. So it is actually like now exited. You can just stop it and start it one more time. Docker start SQL Server Docker. And start that out. Okay, it just started it out. Docker ps -a, you check it, and it says up 4 seconds. So it means your Docker container is again up, and you can just like work it in the normal way, right? Makes sense? Okay, so I hope this gives you kind of a like how we are pulling that image. So if I go back to the presentation just for reiteration, we pulled the image from the Docker Hub repo, then we actually pulled that image into the local databases over here, which is the images, and then from the images we ran our container, and we then continued connecting it with SQL Server or anywhere. Now let's run one more container, but let's say we are running it for a Postgres. Okay, so let's try running it for a Postgres one, and this is another one, which is a simple one. Let's try it before we'll demonstrate the NoSQL also. So now if you see, I still have only one image because we pulled one image, and that's the image which we have, right? We have only the SQL Server image. Now what I'm gonna do is, I'm again saying, hey, pull this Postgres. Now Postgres is another database like RDBMS database, which you guys can use. Somebody, you might have used it somewhere. So you can pull this image, right? It's the same way, just like we pulled the image of SQL Server. You press enter, and it starts pulling it. So again, if you go back to the diagram, you are pulling the image from the Docker Hub repository and pulling it into your local database, right? So it's pulling it up, and once it is pulled, now we would have two images in our local repository, because SQL Server we have already pulled it, and the Postgres. Okay, so it's being pulled up. Now if I just clear it, and I'll say Docker images, if you see that, now you have two images. So one is this SQL Server, and one is this Postgres. This is also tagged latest, just like some size for that. So you pulled it. Now again for this, so let's say the Postgres image is here, but still it is not running as a container. So now if you want to run it as a container again, you would have to run a command called as docker run and run it as a container. So let's use that command, which is almost similar to just like the SQL Server. Just few parameters would change. So if you see, I'm using the docker run command. The name is, I'm giving a container name so that we can start, stop, or remove it easily. Postgres docker, which port? So by default, the port for Postgres is 5432. So I'm using on the local host would be this, and it would be aligned or mapped to the Docker port, which is also 5432. And then I'm specifying certain parameter strings where we are specifying the Postgres password. I'm just specifying the same password. And then I'm running it in the form of a the Postgres latest. That is, this is the image which we used right now. Please run this Docker container from this image. Okay, run this. So if it runs successfully, it gives me a hash. Okay, makes sense. So once it is done, now the Docker container, I have two images now. So two images, and I'm running two containers. One image for SQL Server and a container, and one image for Postgres and a container. Okay, so makes sense. Now, if I just want to see the containers, okay, so you would have two containers now. This is the first container, which is Postgres. Okay, so it is also giving us the name which we specified over there. And then there is a second container, which is for SQL Server. We did specify the name. So two containers, both are up. Okay, makes sense. Both containers are running. And now if I want to connect onto Postgres, you can use an app called as PG Admin. Okay, this is one of just like a SQL Server management tool. You have a PG Admin tool which you can use to connect it. And we can just use the same way. So let's, you just need a password for this first. I've specified a password. Okay, now over here, I just need to create, let me cancel that. I'll create a new server, okay? And let's call it as Postgres Docker server, let's say. Okay, and then I'll go on to the connections. Okay, host is localhost because I'm running it and port is 5432 by default port. Username is always Postgres, just like SA for SQL Server, and password, which we specified, lovely university 123 hash. And then we just simply say save. Boom, you are connected. All the databases, by default, there is a Postgres database, but you can just start creating your database. Everything. So now this is also, there is no Postgres installation, nothing. I didn't install any Postgres or anything. I'm running a Docker container, right? This is the container. So if you just stop this container and then try to connect it, it won't connect because you have stopped the container. But now you're running it, you can just host it, use it in any point of time, right? It's so simple, so easy. I'll tell you, when I actually learned this Docker like almost 5 years back, when I started off with my journey with Dockers and containers, I implemented this in my first job in Canada, where we removed the SQL Server, physical servers, and other database servers. We started using containers because they are faster. You don't need like a Windows machine or a Linux machine or something like that. You just need a Docker desktop software, install it, and start playing with it. So easy, so manageable, and they are quite less on your resources. Like they don't consume as much resources as virtual machines would use. So that's the another beauty of that. Okay, so these are the two which I wanted to touch base on that. You like anything you think about it, you want to run a React app, an ASP.NET Core, or anything. I'll show you another one, which is NoSQL. Like you might have heard about MongoDB or anything. Let's try that also. So again, because we need to go over there, we need to pull this out. And there was one more thing which I wanted to let you know, because in your this one, when you go on to your official image or any other image, so I'm using these commands, like I can give you these commands, but these commands I have not generated it, right? These are standard commands. And some of the commands, like they've already given it to you within the Docker Hub. So you just need to, like, if you want to use this Docker image, you can just copy this Docker pull Redis. So let's say I don't want to run a Redis, but let's say I just want to pull this image. So copy this, go back to this, and now if you see how many Docker images you are running. So you're running 2 because we pulled one Postgres and a SQL Server. Now if I pull this Redis, okay, so you start pulling it. So I didn't even need to know about that command. They have given you all the documentation and everything. So if you see now Docker, and let me clear that, Docker images. So if you run that, so now I'm running 3 Docker images in my local repository. One is Redis, one is Postgres, and one is the SQL Server. But I'm just running 2 containers, right? So if you want to see the containers, so Docker PSA -a, it would give you only 2 containers. I'm not running any container for Redis. Of course, I can run it. So now let's try using a MongoDB. How we use that? It's a NoSQL database. So just Docker pull Mongo. That's the simple command. I've just known it. So if you run it, now what you're trying to do, you are again pulling the image of Mongo from here to your local image. Okay, let's do that. Run this. So it starts pulling your Mongo image. Okay, it does the same way, right? And just puts it into parts and then compile it as a one single file, or the image into multiple parts, because it's faster to download it. Okay, let's give it some time to download it. Okay, it's almost, yeah. So the Docker image for MongoDB is done. Now let's check that. So Docker images, okay. So I have now 4 images. This one, SQL Server, Mongo, Postgres, and Redis. Now let's say I don't need to use Redis, so I can just remove that. Docker remove image, RMI, we call it as a remove image, and you just give the image name, right? So the repository within the image is Redis, so I can just give Redis. So Docker remove image Redis. So it would just remove that image file. So it just untags it, deletes it, and now if I just use it, Docker images, so you get only 3 images right now, because one is Postgres, one is Mongo, which we downloaded it right now, and one is SQL Server, which we are running. Okay, now let's try running MongoDB, because MongoDB is available as an image in our local repository, but we are not running it as a container. So how to run that? So there is another command for running a MongoDB one. So let's try running it. It's a simple command. I'll just explain almost on the same lines, the way we ran it. So we just use again Docker run. I'm sorry. We specify -d as a background process, and then -p, that is your port. Now, MongoDB runs on port 27017. So I'm just using the default port. You can change those ports, right? So this is my host port. It is being mapped to the Docker port, which is running in a virtual environment, 2707. And then I'm specifying the name of the container also. So I'm just saying MongoDB Docker. And then Mongo is the actual command, which would run that instance for you. So you press that enter, okay? So the Docker image is there. Okay, now let's see if the container is running. And for container, all ps -a. So now we would have 3 containers. So if you see, you have a SQL Server Docker container, you have a Postgres Docker container, and you're running a MongoDB Docker container. And if you see, it's created 9 seconds, and the status is up. Up means it's up, and you can connect to that Docker container. And how we are going to connect it? Okay, so like MongoDB or Postgres, you can use multiple ways for connecting that. You can use I would say the PowerShell or the command line argument, but I'm just gonna use so that you can also know, there is a tool called as MongoDB Compass. So MongoDB Compass, I can just if you just search it out over here. So MongoDB Compass, right? So you search out, you can just download it. This is the one, MongoDB Compass. This is the download link exactly. It goes on to this, so you can download that. Okay, which one you want? You want to connect it as a shell or Compass or anything, like you can try out this. This is a free tool. They don't, although MongoDB has a paid version also, but what I'm trying is a free tool. So it's available. You can use this to connect Atlas, which is a cloud version, on-premises, other tools or anything, right? So I have already an installation of MongoDB Compass tool. So if you use that, okay, so let's try using it. So this is a standard tool, just like we used PG admin for this Postgres. So similarly, we have a MongoDB Compass for that image. Now here, if you just want to connect it, so there are two simple things. What you need to do is, so normally it is done through MongoDB, and then you say /localhost, and then colon, and then you specify your port. So 27017. That was the port. If we go back, we check it out. So 27017, that's the port where the host machine would listen, and even the Docker, when it translates, it is listening on the same machine. Okay, so if you just give this connection, that's all. Connect it out. Okay, boom. So you are done, right? You are connected. Let's say you want to create a database or certain collection. I'm not sure whether you guys have some exposure with the MongoDB, but still, it's not something rocket science. You guys can easily do it. So let's say you create a database first. Let me create a database called as Lovely. I want to create a collection called as Department. Okay. So if I create the database, so if you see, you create a Lovely database, and within that, there is a DPT collection. Okay. Now, collection is technically in NoSQL just like a table, right? But we call it as a collection. And then you can have like your own columns or anything. It doesn't follow a fixed structure out there. So what you can do over here is, so you can insert a document, or if you have a file, you can like bring all the documents. So let's say, let me insert our document. Now document over here means a record, right? So you can just insert a document, and it is always in the form of a JSON object, right? So you can just, if you know about JSON, let me just delete this. Okay, so you can just simply say department number. I'm sorry, it's a little small, but I can't really help. This is a tool, how it works. So department number is 10. D name is, let's say, technology, right? And so, yeah, that's how it goes. And you can just say one, we are creating that, and we are missing one comma over here. Okay, we insert that. Okay, so there is now one record out here. You want to insert more? Okay, insert another document. So you say, let's say, we'll just remove this. Okay, this one. Okay, department number, let's say 20, and department name, let's say you give, for example, marketing, something like that, right? Okay, insert it. So you get now 2 records. Okay, so now this one is also, I'm not using any of the, I would say, a case for running it as a MongoDB, like on install and then run it on premise or do it anything. I'm running as a full-fledged container. These are the containers which are running. I can use these containers. I can even back up those containers. I can back up the data which is there in the containers, whatever you want to do. And these containers, they can easily be deployed as it is, like a container being deployed with Azure DevOps or with pipelines or anything onto Kubernetes, onto Swarm, or onto any other environment which you can think about it, right? So that's how things really work. But let's say if you want to, for example, let's say I'll show you a few more commands. So Docker ps-a, you want to see your containers. Now let's say you want to stop a container. So Postgres, we don't need it. So you cannot delete a container directly. The first thing is you need to stop a container. So let's say I'll say Docker stop Postgres. That's one thing which I give. Oops, sorry, we just gave the wrong name. So Docker stop, and then the name of the container is not Postgres, rather Postgres Docker. So that I missed. So I write down, okay. So it would now if I run that Docker PSA, so it has run. Okay, now this is all those are up, but this one is exited, right? So this container, I don't need it. And if I want to remove this container, you can just remove it. So you can say Docker remove, and then you simply say Postgres Docker. So it is all gone. Now, if you see the containers again, you would be running only 2 containers because you have already removed that container. And the another beauty is, so let's say you run one SQL server, right? You can run another SQL server on other virtual platforms or like with other numbers. That's the beauty. Like you don't have to invest heavily into the infrastructure, like somebody gets installing, or somebody doesn't have the software, or you don't know how to install it. These are simple commands rather than like installation. The SQL Server installation, if you have to do, typically it takes around like 30 minutes. I know because I've been installing SQL Server so many times in my lifetime. It takes 30 minutes, and then there are so many options it asks for. Here, you just need to spin up a Docker, get the image, spin it up, boom, run it, and start working it. And then you can deploy it the way you want to deploy it on any one of your containers or any of the cases, right? So this is very, very, I would say, a basic session where, because even if you have to move on to, let's say, the future of this, let's say if you are going for microservices, let's say development, you need to understand like microservices design patterns or anything, whatever you want to understand, you need to understand these Dockers and containers, because microservices are based upon Dockers and containers. Without Dockers, without containers, you cannot move on to microservices, or you cannot move on to Kubernetes or anything. Majority of my projects, which I'm working in Ernst and Young, they are like getting their applications from monolithic applications, which they might have written in somewhere, let's say ASP.NET or React or Angular or anything. Now they are being converted into microservices based, because microservices gives you a lot much flexibility. That's beyond the scope of this session. Hopefully we can have another session where we can go all those in details, but that's something like it gives you flexibility in terms of adding pods, scalability, automatically like adding those pods and everything. So, but before going on to microservices, you need to still spend time upon Dockers. And if you like go with Dockers and containers, so there is a Docker certification also. There are 2 certifications for Dockers and containers. So the Dockers and containers bring in 2 certifications. One is the this one, the DCA, Docker Certified Associate. Sorry, this has only 1 certificate. This is a costly certification. It normally costs around like 300 USD dollars, which is roughly around like 375 Canadian dollars. So I'm not sure how much, but that's what they would be charging. How much you convert, you can do a conversion. But if you feel like, okay, I've done so much practice with Docker and I want to go with that certification, yeah, you can definitely. I'm actually preparing. I didn't find time to prepare for this certification, but this is one of the things which you can go for, right? I hope I've not bothered you with so much, because this is so much of information, but definitely it would help you to give a sense of where you can start off. You have practically seen those technologies in action, like, okay, how it works, how it exactly you can make it work, and what are the advantages of that. So it can definitely help you out. Any questions or any queries, please?
Yeah, if anyone has any question, please ask.
Pooja Goel has raised hand. Pooja, yes.
Yes.
Pooja, you can go ahead with your question, please.
Pooja, you are not audible.
Pooja, are you talking? In case you have a question, you can type it in the chat box in case you're not able to unmute yourself. So we are not able to hear Pooja. Anyone else has a question?
Hello, sir.
Yes.
Sir, I want to know the advantages of Docker containers.
So Dockers and containers, there are so many advantages. One is the cross-platform independence. You don't have to worry about whether you're running it on Windows or Mac or any other. That's first advantage. The second advantage is because if you are going in for, let's say, microservices based, as I was saying that, you cannot go without Dockers and containers. So you need the containerization environment. That's one thing. And the third is like Dockers and containers, they help us to use less of your resources as compared to the other one. Like if you're running a virtual machine, it would definitely consume more resources as compared to the Dockers and containers. So those are typically the major advantages. I hope this answers the question.
Okay. Thank you, sir.
Thank you. Thank you, Susan. Yeah,
Vishwajit ji.
Yeah. Short description. Vishwajit, can you please let me know? I didn't get your question fully. Okay, short description for hosting and making the website and running. Vishwajit, I actually wanted to demonstrate, but then it would have been too much for this small session because if you are going to run a complete website, then you need to have entirely a different game. Like you need to have a Docker image for a Nginx or a PHP or let's say .NET, and then you can host it. These are all the environments, if you can still see my screen. So Azure container, let's say, registry. So this is another I was talking about to host all your container workloads, right? So Azure provides you this registry for Docker and Open Container Initiatives, OCI images, right? So you would be using this one. Nowadays, okay, I'll show you one thing if the time permits. So if you go on to an Azure portal, let's say, let me sign in my. So what happens is, yes, let me. So if you want to host a website, I'm not assuming you guys know about this, but let's say I want to host a app service. Let's say app service, right? Now the app service is like hosting any website in Azure in like a few minutes. You can host anything. You can create an app service plan. Okay, so now when you do this, so okay, where it is, it's not name of the app service plan and zone. Okay, no, not over here. It is in the, let's say, web app. Okay, yeah, web app services. Yeah, let me create this one. Okay, so when you create this, okay, so over here, so if you see, when you supply your web app name, like your website name, you can do it anything. You can specify like publish. You want to use it as a code. You want to use as a Docker container, right? That's the beauty of it. So if I want to host my website as a Docker container, you can host it, right? So that's the, I would say, the basic principles by which this is becoming more popular. But fundamentally, it was beyond the scope of like doing this whole. It would require like another couple of hours to do this whole session, like if I really want to explain that way. Thank you, Vishwajit. Thank you. Docker, okay, Vishnu, Docker desktops does not need license. I did mention that. Docker personal does not need any license. If you have 250 people working under your company, then you need a license, but personal is 100% free. Okay, Umar, he says, any drawback using Docker? Okay, yes, there are drawbacks. I would say security is one of them. Normally they are running as a closed containers, but yes, security is one of the concerns. One container can talk to other and they can be vulnerable or they can be misused. Yes, there are so many. You can definitely read it out. I'm not going much into detail, but yes, it does not come without any minuses, right? Jyoti, does that answer your question also? because you were also asking the same shortcoming of using Docker. Yeah. Anything else? Which is the most secured if not Docker and container? Then, okay, that's a very relative question. There is no term called as, we put it into double quotes, that is secured, right? There can be no system which is secured. It is only like how much security you enhance, that's all. So if you say Dockers are more secured or that is more secured, I don't get into that. But you try to adopt the best practices, Mohit, that would be more important. So somebody asked me, like I still remember I was working with LPU and Dr. Vijay Gupta was the vice chancellor at that time. He asked me one question like, Rohit, how our systems are secured? I said like they are as secured as Microsoft and they are as vulnerable as Microsoft, right? Because the reason for that is because we are using the same set of technologies. If they can be hacked, we can also be hacked out, right? We are not using something out of the box. So it's the same way, right? Mohit, does that answer your question? Okay, anything else? Any other question? Prabhat, yeah.
Prabhat has raised. Yeah, Prabhat, ask your question, please.
Thank you, Mohit. Prabhat, you are not audible. Probably you can type your question. Prabhat, I don't think so. He's typed the question even.
Any question from anyone, please?
Is it
there is one
possible to patch the Kishore from Kishore the Docker image and always keep it updated with the new updates? You don't have to, Kishore, patch the Docker image. You can always pull the latest one because it is hosted. It is going to be provided by some company. So let's say you're using the ASP.NET image. You are going to get it from ASP.NET Microsoft's image. So they are already patching it. The only thing is you just need to get the latest image and then start using it. That's all. Yeah. But yes, it is visible. We need another session for this. This session was amazing. Thank you, Deep. Thank you for these kind words. Really appreciate it. I hope I was able to at least convince or give you something like, okay. That's why I kept my presentation small. What is gig role in EY? I didn't get you, Harsh. Gig. Are you asking about my role or?
Yeah, Harsh, could you elaborate your question, please?
Yes, because gig, I cannot understand in what context you are asking. What is gig? Prabhat, if you can just go, and Rajiv Kumar have raised their hands. Oh, he's asking about the freelancing work. Freelancing work, okay. EY, as such, if you talk about the freelancing work, Harsh, if you're asking about that, EY does not do a like kind of a setup or arrangement with the freelancers. EY is like one of the companies of Big Four, we call it as, where we have a EY, we have a Deloitte, we have a PwC, and we have KPMG, right? And you were recently selected in EY GDS consulting team. I received mail you were selected for gig role in EY. The GDS team is an Indian team, like the Asian region, what they call it. I know I have worked with the GDS team. I'm still working with one of the projects out there, but I'm not sure about the gig roles because I'm into the Canadian teams. So I'm not sure if they have specific like nomenclature for that. Probably might be something to do with that. I'm sorry, I don't know much about that. But for the freelancers, they don't really work with the freelancers. They either hire you as a full-time employee or they hire you as a contractor. Like you can work as a contractor, which is for like 1 year or 2 years or something like that. You're welcome, Harsh. Thank you. What command should you run to see all the running container in Docker? So containers, that's ps -a. So I've typed that command, Shivam, in the chat window. And this is to see all your images, which you have downloaded it. Thank you, Shivam. Yeah, please, you can just even before, you can even go on to my channel and see what kind of videos I normally post. So you would see so many videos. This is for the masterclass, like Apple Silicon, MongoDB with Dockers, laptop configuration choices, or anything. Like you can just go on to this, subscribe it. I keep on posting it. Try to, and whatever I feel looks good or something which can be helpful to the community. Systems requirement for Docker is not something very big, Rajiv. You can run it on even an 8 GB or a 16 gigs standard PC. That's fine, nothing. Because if you want to run a virtual machine, you might need a bigger one. But for this Dockers and containers, 8 gig, I would say is the minimum one. But if you have a 16 gigs, it's definitely recommended. No, you can let me know. You can send an email to me regarding what kind of a problems we can take it offline. I can respond back to you on email what problem you're facing while installation. I don't think so you should get any installation issue or anything. Once again, this is my the email and my, for your reference, my last name, my first name @Gmail. I do have a Hotmail also, but normally I check this one. This is my LinkedIn. This is my YouTube. So, yeah. Yes, it works on a 64-bit. Yes, I assume you have a 64-bit machine also, Rajiv, because normally people are running Windows 10 and oh, you tried it on a, no, you would have to do it on a 64-bit. Yeah, sure. I was assuming you're running it on a 64-bit. Yeah. Thank you, Rajiv. You're welcome. Okay. Anything else? I hope everyone liked this session and it's going to be useful for all of you.
Any other question by any of the student, please?
Thank you, Kushbu. Thank you, Yela.
So, Manish sir, are we done? Can I formally thank sir, please?
Yes, ma'am. I think, ma'am, it was a great session by sir. Thank you, sir. I think with a very good presentation and a very good practical knowledge that sir has given. Now, I would request ma'am to give a vote of thanks for today's session by the sir. Over to you, ma'am. Thank you.
Good morning, sir, as per Indian time, and I'm sure it must be 11 there in Canada.
But
So,
it's a weekend. It's a weekend, so don't worry. It's okay.
It's a weekend, but still we have you up and energetic in the middle of the night. On behalf of the staff and students of LPU Online, I would like to thank Sir for the most valuable thing that anybody can give us, that is Sir's time. I think it's invaluable experience, not only for the students, but even for all of us to listen to you.
Thank you.
I want to tell the students that Sir joined LPU in 2001 and left in 2015. And Sir had joined as a lecturer. And anybody talented, when comes to the land of opportunities that LPU is, rises and shines and touches lives. Sir left us in 2015 and moved to Canada. And that time, Sir was heading the division of IT. And Sir made us all look at IT in a very, very different way, and made us realize the potential that in-house team has and a difference it can make to the entire setup of the IT infrastructure in any institution. And we are looked upon by others in a way that, how the kind of facility and the kind of IT infrastructure that we have today and we can boast of, we owe it to Sir. And Sir is one of the most respected persons at LPU. And even after 7 years of leaving LPU, Sir is still fondly remembered by each and every person, not only the staff, but also the students. And it's rare that we come across such a person in our lives. And you could have seen today in the entire presentation, a person with such stature, so calm, composed, and so soothing it was to hear you, Sir. And I'm sure students are extremely amazed by your personality, by the knowledge that you have, and will definitely carry home a much bigger feeling about what they have enrolled for. We will have another session by Sir, hopefully very soon. I'm sure students want more. It was a total pleasure. And I am glad that being at the helm of affairs for online learning, we are able to provide such platforms and interactions to our LPU online learners. It was a complete pleasure, Sir. Thank you so much. And we look forward to having you again.
Thank you, ma'am.
Minister.
Thank you for all those kind words.
Thank you, sir.
Really
Thank you,
remember all the sessions we had, the times we have spent. It's like a homecoming for me. I've mentioned in my video, yeah.
Yeah, thank you so much. Thank you, Minister. Thank you, Kulvinder sir. Thank you, Anna ma'am. Thank you, Neha ma'am. Thank you to all the people. Asim sir, I'm sorry if I miss out on anybody. I think Ajay sir is missing. And it was a pleasure having everybody and organizing this. Thank you so much. And we look forward to having you again.
Thank you.
Thank you,
everyone.
for your time.
Thank you so much, ma'am. Thank you so much, sir, for the wonderful session.
Thank you, Manish.
Thank you.
Thank you. Bye-bye.
Thank you. Bye-bye.
May I enter this, sir?
Pardon, sir.